So this looks kind of messy, but the best thing to do is always start with factoring because you might be able to cancel factors. So we're going to go ahead and do that. What does the numerator factor to? Anybody know? X minus 4 and x minus 4. Okay, and then if we do the denominator, what can I factor that denominator to? I have negative 24. I have to have factors that add up to 2. Yes, x plus 6 and x minus 4. Oh, well look at what happens here. You can cancel factors because they're like a number inside parentheses. So you can cancel these two. They divide out. It's like equaling 1. So what you're left with is the simplified form, and you just rewrite it. And that's all you got to do for that one. Okay, the next one's pretty much the same. You got to look at the numerator and say, how can I factor that? What can I pull out of each term? I can. A 20. I can pull a 20 out of each of these terms. And in the front term, I'm left with 2x, and 20 divided by 20 is just 1. So that's my numerator. And then the denominator, what can I pull out? 10, and it's x plus 3. It doesn't do much for me except for one thing that I can simplify here. What can I do? 20 divided by 10. So it just leaves a 2 in the numerator, and it's 2x plus 1 divided by x plus 3. You could put it in parentheses or not. It doesn't matter. That's really all you can do with that one. Okay, I'm going to work down here. So the numerator, what can I pull out of both terms of that numerator? A 2x. So I'm going to do that. If I pull a 2x out of here, what am I left with? Just an x and then a 5. And that's my numerator. But we have a little situation in the denominator. What's the situation? The leading coefficient is not 1, right? So I'm going to use a box. That's how I like to do it. I don't know if you didn't have me last semester. I don't know how you guys learned, but I like to use a box. When I have something that's not a leading coefficient of 1, you fill in the top and the bottom box. And then what's that little step that you have to add in? You have to do 3 times 5, which is 15. And then factors of 15 that add to 16. What is it? 15 and 1, right? So I'm going to put 15x here and 1x here. Have you all seen the box method?
Yes.
Okay. And then you pull out what you can pull out. I can pull a 3x out of here. 3x times x gives me that. 3x times 5 would give me 15x. So that goes up there. And then this is just 1 here. So my factors are x plus 5 and 3x plus 1. How does that help me? I can cancel the x plus 5s. And I'm left with 2x over 3x plus 1. Simplified. Questions so far? Because it gets better.
Oh God, that's really gross.
All right, what does this dot mean right here? Multiply. When you're multiplying fractions, what do? Just straight across, right? You're multiplying the numerators together and you're multiplying the denominators together. Okay? So, you have options here. You could just pretend this is like one long fraction bar, because really you're just multiplying the two together, right? And then you can reduce numbers if you want first. It doesn't matter. That's kind of what I did. I said, oh wait, 27 divided by 3. Have you ever seen this before, canceling? Yeah. That gives me a 9. Correct? I think that's a little easier. I have 5 and 15. I can cancel the 5 and make this a what? A 3. So that makes my numbers a little easier to work with. You've seen this before, right? Nothing new, hopefully. So what number am I left with in the numerator? What coefficient am I left with in the numerator? A 9. Okay? Now I'm going to look. Okay, I have base x, base x. What do I do to the exponents when I multiply them? Add them. So I have 7 x's in the numerator and 3 y's in the numerator. So I took care of the numerator for now. What's the coefficient in the denominator? Yeah, I could have gone further with that, but that's okay. We can take care of it still. I have 1x base and x4. So how many x's do I have in the denominator? X to the 5th and y to the 5th. Now we're not done yet. Oh, this is where everything you learned comes into play. What's 9 divided by 3? Okay, so I'm just going to put 3 in my numerator. X to the 7th divided by x to the 5th. X squared on top, right? There's more x's on top. Yeah, and then this is minus, and since there's more y's on bottom, that's where the remainder ends up. Remember that? Okay, so there's that one. Could you put the 3 out front? Absolutely. It can look like this. That's absolutely fine. Doesn't matter. Okay, let's try this one then. I'm going to put a long line here if you want, if that helps. It doesn't really matter. I'm going to see if I can simplify anything. I could cross out the 3 and make that a 3. It might help a little bit. There's some other things I could do as well, but we'll just leave it like that for now. So in my numerator, I have a 6. X to the 5th times x gives me x to the 6th. Y squared times y squared gives me y to the 4th. That's my numerator. My denominator, I have 8 times 3, which is 24. X to the 1st power times x to the 3rd gives me x to the 4th. And y squared. Good where I'm at so far. Stop me if you're not. Okay. I can reduce this fraction. 6 over 24 reduces to what? 1 over 4. I'm just going to rewrite it as 1 over 4. Now I'm going to look at the x's. There's 6 on top, 4 on bottom. That would leave me with what? X squared on the top. Look at the y's. 4 on top, 2 on bottom. So if I cancel 4 minus 2, I have 2 left on top. Okay, so you can leave it like this. I don't care. Or you could write it like x squared times y squared over 4. It's the same thing. Or 1/4 x squared times y squared. It doesn't matter. Okay? Okay, here we go. More fun on the back. Okay. I'm going to have you write this up here because it is going to visit us again. Difference of cubes. We'll be using that. Okay? All right. So let's do this first one. Again, we're multiplying, except we've got a couple of things going on here. So it's kind of yucky. What I would recommend is factor each thing first. I probably shouldn't have drawn that line there, but we're going to factor each thing first. So I'm going to look at this 20 minus 5x squared. What can I pull out of there? A 5, and I get 4 minus x squared for that. I'm going to keep that times here, and I'm going to do this one here. How can I factor that? -4, factors of -4 that add to +3. Plus 4 and minus 1, right? So I'm going to write that as x plus 4 and x minus 1. Then let's do the denominators. What can I pull out of that one right here? An x. Pull an x out and I get x minus 1. Okay, this is a difference of a perfect squares. So what does, if there's no middle term, what do my factors look like? X plus 4 and x minus 4. Okay, now let's look and see what I can cancel. So I can cancel this, I can cancel this, and that's all. So then let's write what's left over. Again, since you're multiplying, you just multiply straight across, and that's how I ended up with that. Okay? How you feel about that? It's kind of fun. Let's do the next one. Okay, we're going to factor each little thing first. This numerator, let's factor that numerator. What can I pull out of there? A 2x. And I have x minus 5. Factor the denominator again, that's the perfect square thingy. And there's no middle term, so it's going to be what? Yeah, and it doesn't matter what order you write it in. Times x plus 3. And then I'm going to say, does it help me to split this up? Look, I have a 2x here. Sometimes you have to stop and say, oh, maybe I could write it like that. Look at that. That'll help me get rid of something. Right? So let's cancel what we can cancel. This and this. 2x and 2x. X minus 5. I think that's the fun part, crossing crap off. Isn't it fun? Then what are you left with? X plus 3 over x plus 5. Look how pretty that is. Now, common mistake. People want to cancel these. Why can't you? You cannot cancel these x's. Yes?
Question. What happened to the other x?
Yeah.
Oh, as I said, there's an x down here.
Oh, okay.
Thank you. It's even on my notes, and I didn't write it down. So, again, why can't I cancel, let's say, these two x's? People want to do that, and you can't. It's because it's being added to 3. I can't do that. I could cancel the whole factor, because they're exactly the same. But when it's being added to something like that, you cannot cancel those. Okay? All right. Answer. All right, let's do another one. I know it looks like a lot, and it kind of is, but... All right. There's not much I can do to this numerator, but I'm going to place this over 1 just to help me see things correctly. It's a fraction. I can make it into a fraction by placing it over 1. So the x plus 5 is going to stay the same. However, this is the difference of 2 cubes. What's negative 1 times negative 1 times negative 1? Negative 1. It's a perfect cube. Okay? So I'm going to use this pattern right here. So I'm going to write x minus 1. That's what a minus b is. This is my a, this is my b. And then I'm going to write the other part of it. It says, okay, square a, add x times negative 1. I wrote that. That doesn't seem quite right. Oh, yeah. Yes, because you don't consider the negative. You just consider the b as 1 for that. Yeah, b is just 1. Right. Right, because of the formula. And then it's times, I got to factor the top thing here. Can I factor that? X squared plus x plus 1? Think about it. Can you factor it into anything? Factors of 1 that add to 1? No. So it stays the same. Over 1. Okay, what can I cancel out? This big thing. It's exactly the same, so I can cancel it out. And then I have x minus 1 times 1, which is just x minus 1. Okay, so those are those. Now we got to go to divide. But really? Flip the second guy and multiply. Have you ever heard that before? Dividing fractions, all you do is take the reciprocal of the second one and multiply. So it's really the same process. Okay? So I'm going to rewrite it though. X squared minus 4x minus 21 over 5x plus 15 times x squared minus 100 over x squared plus 3x minus 70. You have to flip this second one and rewrite it as a multiply. And then you do the same process. So let's factor the numerator. What are factors of that? Negative 21 that add to negative 4. Factors of negative 21. Correct. Yes. So I'm going to write it as x minus 7 and x plus 3. Negative 7 and 3 add to negative 4. What can I factor out of each term here? A 5. And then times, oh, perfect squares, no middle term. What is my factors going to be? X plus 10 and x minus 10. And then factors of negative 70 that add to 3. You're like, oh, no way, but don't panic. It's not that bad. What do you think it is? 10 and 7, right? 10 and 7. So it's got to be x plus 10. And sometimes it helps to look at what you have up here. That might give you some guidance as to what to use. X minus 7. Oh, we got all sorts of things happening here. Slash, 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 slash. Oh, look at that. It's a beautiful thing. Would you look at that? And we have x minus 10 over 5. Isn't that gorgeous? One more. It's not too bad, but we have to do the factoring with the box. So I'm going to do that one more time with you. Okay? So I'm going to write this over because I have to do what to the second fraction? I'm going to place this over 1 and then flip it. Place it over 1 and flip it. Take its inverse or reciprocal or whatever you want to call it. Now I factor each thing. Okay, oh, I have a leading coefficient that is not 1. I'm going to do the box. Okay, I get negative 30 when I do 3 times negative 10. Has to add to 13. Factors of negative 30 that add to 13. 15 and negative 2, correct? Okay, so I'm going to write 15x and negative 2x. Pull out a 3x. 3x times x gives me 3x squared. 3x times 5 gives me 15x. Negative 2, just check, yep, that's it. So those are my factors for the numerator, okay? 3x minus 2 times x plus 5, that's the numerator. That numerator goes to this. This one here, I'm just going to leave it for now. I don't think it helps me. I could rewrite it as 6x times x. I don't know. We'll see if we need that. Times 1 over, and what can I pull out of here? An x, and I'm left with 3x minus 2. And I can only do one little cross off. So now with what I'm left, I go, again, I multiply straight across. X plus 5 times 1 is just x plus 5 over 6x squared. And that is it. Damn. Oops.